Welcome to Ask and Learn.
We are going to find the absolute minimum and absolute maximum values of the function f of x equal 5 plus 54x minus 2x cubed on the interval 0, 4. So the first thing we're gonna say is that this function is a polynomial of degree 3, so it's continuous everywhere, in particular in this interval 0, 4. And being this function continuous on a closed interval, we know it attains its extreme values, that is, the absolute maximum and absolute minimum values of this function on this interval exist, and they are images of some points in this interval. And we know more than that. We know that the points where the extreme values can be attained are either the endpoints of the interval or critical points of or critical numbers of f. So we gotta find all the critical numbers of f which lie inside the interval 0, 4. And with those critical numbers and the endpoints, we evaluate at all those points, and the largest value will be the absolute maximum value of the function over the interval, and the smallest of the values of those values will be the absolute minimum of the function on the closed interval. So that's all is happening here. So we find the derivative of this function in order to find the critical numbers, and this is 54 minus 6x squared. And this function exists for every x in the interval 0, 4. It means that the only critical numbers of this function are those values of x for which the first derivative is equal to 0. So when we solve this equation, we are finding all the critical numbers of f. So we start with this equation, f derivative equals 0, and that's the same as 54 minus 6x squared equals to 0. And then it's the same as 6x squared equals 54. And this is the same as x squared equal to 54 over 6. And this is the same as x squared equal 9. And this is the same as x equal 3 or x equal negative 3. So we have two solutions to this equation here, but remember we are looking at critical numbers in the interval 0, 4. That is why we only are interested in the solution x equals 3. So we say that since negative 3 is not in the interval 0, 4, we know that the only critical number of f in the interval 0, 4 is 3. And so we get to evaluate the function at 3, at the critical number, at 0 and 4, which are the endpoints of this interval. F at 0 is 5. F at 4, which is the right endpoint, is 5 plus 54 times 5, sorry, times 4 I meant, which is the argument, times 4 minus 2x cubed, that is 4 cubed. Doing all these calculations here, we get 93. And finally, F at the critical number 3 is 5 plus 54 times 3 minus 2 times 3 cubed. And this gives us 113. So we can see here that this is the largest value of those three values. So this is the absolute maximum of the function over the interval 0, 4, and the smallest of these three values is 5. So this is the absolute minimum of the function over the interval 0, 4. So we give that answer now. So the absolute minimum value of f on the closed interval 0, 4 is 5, which occurs at 0, which is the left endpoint. At the left endpoint, x equals 0. And the absolute maximum value of f on the interval 0, 4 is 113, and this occurs at the critical number 3. And that's the answer to this problem. It's very important to remark then that we use first the fact that a continuous function on a closed interval attains its extreme values, that is, it has an absolute maximum value and an absolute minimum value over that interval. And in fact, those extreme values are attained at either the endpoints of the interval or at critical numbers. So we find the critical numbers inside the given interval, then reevaluate the function at those critical numbers and the endpoints, and the largest of those evaluations is the absolute maximum value of the function over the interval, and the smallest of the images we found this way are or is the absolute minimum of the function over the interval. And that's the final solution.